Yeah, I think we're a bit more comfortable with what we're doing here. I think the main important things to take away are, we use the quadratic formula to find solutions. The discriminant tells me how many solutions there are, okay? For the most part, it's just substituting numbers into a formula and then seeing what that answer is. Sometimes they can make it a bit trickier by changing the question slightly, or we can still use the same kind of tools, right? Look at this question. Find the value of k so that x squared plus 2x plus k equals 0 has one solution. So there's a couple of things going on here. Just a show of hands out of curiosity, who actually had a go at this question? Yeah, okay, about half of you, all right. Let me just think about what I know here. First of all, it's different because this quadratic equation, there's no number here. They've replaced it with a letter, right? But just think back to what algebra is. Algebra is using letters to replace numbers. So I know that k could be a number. I don't know what it is yet. I'm going to find it, but for now it's just k, okay? And I want to find the value of k so that this equation has one solution. So that's immediately telling me I'm interested in how many solutions there are. Not what is the solution, but how many solutions. Tamara, can you remind me again? If something has one solution, what does the discriminant equal? 1. Okay, so that's my first clue. For this equation here, x squared plus 2x plus k equals to 0, if I wanted to have one solution, I'll let the discriminant equal to 0. But that's not really too helpful, is it? Because the discriminant equals 0, I can do better than that. What's the formula for the discriminant? A times c, yep. So b squared minus 4 times a is ac. I want that to equal 0. But I can still keep going, right? Good, thank you. Good pickup. B squared minus 4ac equals 0. Again, just to make it really clear here, I'm going to write out my values. A equals to 1, B equals to 2. What's C equal to? K, right? Remember, algebra is just using letters to replace numbers. K is also a number. I don't know what it is yet, but I'm going to find it. And then I can just substitute that in. B squared is 2 squared minus 4 times 1 times k equals to 0. That's just 4 minus 4k, because 4 times 1 is just 4. What you get here, this is just a normal equation, right? You've been doing these ever since junior high school. But now we're just tying up all these concepts together. You can just solve this as you would normally. I just add 4k to both sides. So 4 equals to 4k. And then what's the last operation I want to do? I just want to, well, remember, this is multiplied by 4. I just want to divide both sides by 4. So 1 equals to k, or just k is equal to 1. So you can see how we went from something that seemed a bit strange, and we just tied all those concepts together. I know that discriminant equals to 0 if there's one solution, and so I can just find, by solving that, that k is equal to 1.
Sure.
Any questions about that?
What if there are 2 solutions? It could be anything positive.
Yeah, so that's actually the next question. What if I wanted 2 solutions? It would be, when does an equation have 2 solutions?
When it's positive.
When it's greater than 0, yeah, when it's positive, right? But this one has 2 solutions, has real solutions, okay? The reason why they phrased it that way is because, well, if they're real solutions, there must be something called, like unreal or imaginary solutions. And that's something that you actually look at in the extension 2 mathematics, that there are, I've told you this whole time that you can't find the square root of a negative number. That's true to an extent. If you look at extension 2 maths, there are some things we can do with negative square roots. So we're not worrying about that for now. Has real solutions is implying that I want the discriminant not just to be greater than 0. What else? Maybe just write this out. Real solutions, I can have 1 or 2 solutions, right? When does my quadratic equation have 1 solution? When it's equal to 0? When does it have 2 solutions? When it's greater than 0? Can I put those together, Amelia? How could I write that? What do I want the discriminant to be?
Greater than 0.
Just greater than 0?
Greater or equal to?
Or equal to, right? So now we've got an inequality here. Now we've got an inequality. It can be greater than 0, but it can also be equal to 0. So we put those together, just greater than or equal to 0. And again, I know that I can write my equation here a bit better. So I want b squared minus 4ac to be greater than or equal to 0. What's that here? That's minus 2 all squared minus 4 times 5 times k just simplify it out. 4 minus 20k is greater than or equal to 0. What can I do here? What can I do here to solve it? So, I mean, the simplest way to do it is, let's just get 20k to the other side, right? I can just add 20k to both sides, right? 4 is greater than or equal to 20k. And then that's just, oh, I'm trying to find a value for k.
How do you divide 4 by 20?
Yeah, divide both sides by 20. So 4 over 20 is greater than or equal to k. But usually you write the answer with the variable on the left-hand side, right? So I'm just going to swap these around. I'm allowed to do that. That's k is less than or equal to, yeah, if you put that in your calculator, you get 1 on 5. So you notice for this one, right, it's different because the previous one said, I just said find the value of k. But this one says find the values, right? Here I've got a range of values that k can be. It's not just one number. As long as k is less than or equal to 1 on 5, then my quadratic equation is going to have real solutions. Does that make sense? Yeah. Any questions about that?
Yes.
Not too bad, right?
Pretty G.
This one though, this one is a bit of a doozy. Did anyone try number 3?
Find the value of k, so
Yeah, I want to find the value of p so that this thing only has one solution. So think about how I've done over here. How would I start? Something like this.
No clue.
No, that's one solution.
The clue is, look at the question, the words of the question. It's no different to all the other ones that we've been doing. This is the thing with mathematics, right? Yes, the questions can look different, but the principle is always the same.
it has to be equal to 0.
Yeah, good Rip. So that's my starting. I want the discriminant to equal to 0. So I want b squared minus 4ac to equal to 0. I'm actually going to go over the side here and do the same thing as I did before. I actually want to find those a, b, and
So
c
there's p
values.
plus 1, there's whatever coefficient.
Okay, so let's just do a and c really easily first. A and c are obviously just 1 and 4. Those are the numbers there. But Rips has realized, hang on, remember, what is b? Well, b is just whatever's in front of the x. What's in front of the x here? P plus 1. P plus 1 is what's in front of x. So my b, my coefficient of x, I can just write that as p plus 1. That's it. Okay. See, I haven't done anything different here. It's just the only thing that's different is that, oh, my coefficient now looks a bit more complicated. But I can still do this in the same way, right? When I put this and I substitute this all in, Matt, what am I going to get here? Yeah, p plus 1 squared minus 4 times a times c. Well, that's easy. That's 4 times 1 times 4. That's just 16 equals to 0. Now, there's a couple of ways you can approach this. In this case, what's one thing I could do? Yeah, Matt?
So I got p equals 1.
Okay, before I do that though, I'm going to take the 16 to the other side, okay? So p plus 1 all squared equals to 16. Now, Matt said that we want to take the square root. It can be easy to say, oh, just take the square root of both sides and I'll get 4 on the other side there. What have I forgotten there?
Oh, c equals 4.
Every time you apply a square root, you need to think about the positive and negative cases, right? If I take the square root of both sides, I get rid of this square root here. But over here, I get p plus 1 is equal to plus or minus the square root of 16, which is just 4. And you're actually going to have 2 answers for p now. P will either equal to, so what's that? So I just put the minus 1, I put the 1 to the other side, I subtracted 1 from both sides. So p is either going to equal to minus 1 plus 4, which is just 3, or minus 1 minus 4, which is just minus 5. Okay? So in the same way, in the quadratic form, you have plus or minus. We can also have 2 solutions like this. Just write your name down. So minus 1 plus 4 is just 3, or minus 1 minus 4 is minus 5. No! Okay, so that's a good question. What is this one solution referring to? Is it? Amelia? Sorry? It's referring to, okay, this is the clarification, right? I can have a solution to a quadratic equation that can have 2, 1, or 0 solutions, but this is a variable inside of that, right? So it's saying find the values of p here that make this equation have 1 solution. Can you see that difference there, right? So there's 2 things I'm trying to answer. I'm trying to say, when does this have 1 solution? What is the value of p that will give me this quadratic equation to have 1 solution?